Good evening. I'd like to talk about the standard form of linear equation and solutions. Let's understand what's the meaning of the standard form of a linear equation. If we have an equation written with this form, ax plus by equal to c, so we say that this is the standard form of the linear equation. See that this equation contains two variables, which are x and y, and we have three values, which are a, b, and c, which are the constants. So these are some examples of linear equation with the standard form. We have 2x plus 3y equal to 5. So the coefficient of the x is equal to 2. So a is equal to 2, and b is the coefficient of y. So b equal to 3, and c is the right constant. So c is equal to 5. X minus 2y is equal to 0. Again, this is a straight line. And we have the value of a, which is the coefficient of x, is equal to 1. And b is minus 2. And the value of c is equal to 0. Minus x plus 1/2 of y equal to 1. Again, this is straight line equation with the value of a equal to minus 1 and b equal 1/2, and the value of c is equal to 1. See that this equation is not in its standard form, which is y equal to 4x minus 3. Simply we can change this equation to its standard form. So the value of a is minus 4 and b equal to 1 and c equal to minus 3. We'll see now. Change the equation y equal to 4x plus minus 3 to its standard form, ax plus by equal to c. See that we have the variable y is alone at the left side of the equation, so we need both x and y to be at the left side. So simply we can subtract 4x from both sides of this equation. So the left side of the equation becomes y minus 4x, and the right side becomes 4x minus 3 minus 4x. Now we can simplify. For the right side, the 4x cancels with minus 4x. So what we have here, we have y minus 4x equal to minus 3. We can simply rearrange between the two terms at the left side. So after rearranging, we have minus 4x plus y equal to minus 3. So now we can identify the constant and the coefficient of this standard form of equation. We have the value of a is equal to minus 4, which is the coefficient of x. The value of b is the coefficient of y, which is 1. And the value c is the right term, which is the constant, which equal to minus 3. Let's understand this straight line. This straight line is a representation for the equation of y equal to x plus 2. So this is the graph of this equation. So what we have here, we have straight line, and we say that any point lies on this straight line is considered as a solution to this equation. For example, if we check for this point with coordinate of 3 and 5 and substitute it in this equation becomes true. And if we try to compute the coordinates of this point, which is outside the line, we see that the equation is not balanced. So let's check first for the point with coordinates of 3 and 5, whether it is a solution or not for this equation. We can simply conclude for this by two ways. The first one is to plot the point 3 and 5. So to plot for point 3 and 5, this is the point for x equal to 3, and this is y equal to 5, and this is the point of 3 and 5, so it is a solution for the equation. Simply we can also check for this by substituting the coordinates of the x and y. So this is the equation, y is equal to x plus 2. So we need to substitute. So y we have 5 is equal to x, which is 3 plus 2. We need to check for this equation, whether it is stable or not. We see that the right side and left side, the result is 5, so the equation is true. So we say that the point 3 and 5 is a solution, and again it lies on the straight line. Let's check for the point with coordinates of 1 and 2. If you try to plot it on the plane, you will see that this point represents the point 1 and 2. So it is not on the straight line, so it is not a solution. And simply we can check for this by substituting in the equation. So this is the equation. If we substitute for x to be 1 and y to be 2, so we have y equal to 2, and the right side is x plus 2, 1 plus 2. We need to check for this statement. So the right side is 3 and the left side is 2, so the equation is not correct. So we conclude that this point is not on the straight line and it is not a solution for this equation. Let's see this example. For each order pair, we have 4 points with coordinates of x and y. We have a 0 and minus 4, b 3 and minus 1, c 2 and 2, and d 1 and minus 5. We need to decide whether these order pairs is a solution of the equation, and this is the equation, y is equal to x minus 4. And the second thing is to conclude that if this point lies on the line or not. So let's start with point A with coordinates of 0 and minus 4. We will solve it by two ways. The first way is by plotting this point on the plane. So for x equal to 0, we start here from the origin, and y equal to minus 4. So we should move downward till we reach the value of y minus 4. So as you see here, the point A with coordinate of 0 and minus 4 lies on this straight line. So it is a solution to the equation. And simply we can check for this. This is the equation. Substitute for x equal to 0 and y equal to minus 4. So the left side of the equation becomes minus 4, and the right side, which is x minus 4, which is 0 minus 4. So both the left and right side are the same, so the equation is true. And because the equation makes the point at the straight line, so point A is on the line. Let's check for the second point, point B, with coordinates of 3 and minus 1. Let's plot this point on the plane. So we have for x we have 3, so this is the value of 3. And for the value of y we have minus 1. So we need to move downward till we reach the value of y equal to minus 1. So this is the point B. So as you see here, the point B is on the straight line, so it is a solution for the equation, and simply we can check by substituting. So substitute for x equal to 3 and y equal to -1. Y is equal to -1 equal to x minus 4, x equal to 3 minus 4. We need to check both the left side and the right side is -1. So we conclude that this point is a solution to the above equation. And because it is a solution for the above equation, it should lies on the line. Let's see the third point, point C, with coordinates of 2 and 2. Let's first plot this point on the plane. So the value of x is equal to 2 and the value of y is equal to 2. So this is the point C. So as you see here, point C is not on the line, so it is not a solution for this equation. Simply we can check by substituting. So this is the equation, and this is the coordinates of the point C. So if we substitute, the value of y is 2, and the value of x is again 2. So we need to check for this statement. So we have at the left side, we have +2, and at the right side, we have -2. So the equation is not true. So we conclude that point C is not a solution for this equation. And because it is not a solution for this equation, it is not on the line. Let's check for the last point, which is point D with coordinates of 1 and -5. Let's first plot this point on the plane. So this is 1 and -5. This is -5. So this is the point D. So as you see here, point D is not on the line. So it is not a solution for the equation. Simply we can check for this by substituting in the equation. This is the value of y, -5, and this is the value of x, which is 1. So we need to check for this statement. For the left side, we have -5, and for the right side, we have -3. They are not the same. So this point is not a solution for this equation. And because it is not a solution for this equation, it should be outside the line. So point D is not on the line. That's all about graphing a linear equation by plotting. If you like this presentation, click on the like and subscribe. Thanks a lot. Goodbye.